Hello and welcome back. Today we're going to be getting into some dang tricky stuff. Tricky! Also known as electrons. Electrons kind of do some crazy things, so pay attention. As we start talking about electrons, it's important to remember that electrons give atoms their chemical properties. So that means changing color, lighting on fire, all the fun stuff that we know that chemistry can be and chemistry can do. It's pretty much the electrons that do that. So it's important to know where the electrons are at. Where are my electrons at, yo? This will help us later on as we start determining what the chemical properties of things are and how stable atoms are, and also just some of the normal properties that elements are going to have. So as we go through this, remember those latest electron models. We went over these in the last video, and we talked about how Mr. Bohr, that boring dude that's not really boring, those cool chemistry old dudes, came up with the model that said electrons are at fixed distances in the atom. And we also had that electron cloud model. Okay, so we're going to kind of combine some of those ideas to understand where those electrons are at, yo. Okay, so as we start talking about these energy levels, this is kind of how we're viewing the atom here. We have our nucleus that's in the center. We know that that's a positive charge. And we have our electrons that are traveling around the outside. Remember, Bohr said that these are in fixed positions. And each possible orbit has a fixed energy. The closer you are to the nucleus, the lower energy you have. So these electrons would be low, and as we go further out, these electrons would be higher energy. It takes more energy to go around that bigger circle. And we say that a quantum of energy, or a fixed amount, is required to move from one energy level to the other. These electrons don't have to stay in one place. They can hop back and forth. If they go out, they need energy to get there. If they're coming back in, they're losing energy because this is a lower energy level. And an electron can gain or lose energy by jumping back and forth, but it's important to notice that these are like rungs on a special ladder. These energy levels are not all evenly spaced. So sometimes if you're way out here, you may only have to jump that far. You're not changing very much of your energy. But if you're having to make this leap, there's a lot of energy change going on there. Now this can be a little confusing sometimes. So you can kind of think about it like a track. If you think about the Olympics, when they're running their big long races, like the 2 mile or 4 mile, or I don't even know how far they run. But you notice that all the runners always try and go to the inside lane. They may start out here in these 7th and 8th lanes, but they all want to go to the inside. Well, that's because the inside track is shorter. It doesn't take as much energy to run that inside track. Whereas if you were taking this outside track, it would take you a lot longer. Electrons are kind of the same way. Less energy is going to be on the inside. More energy, it's going to be on the outside. If you think about a racetrack, same thing is happening there. People don't usually like to be out here on the corners because they have to go faster in order to get around those inside cars. The inside position is the best because it's the lowest energy. So when we're talking about energy levels, we designate them with the letter N. So whenever you see this N as we're talking about electrons, think self, that means energy level. So we can have an energy level 1, 2, 3. As those numbers get higher, the energy gets higher. So this energy level here, it's the first one closest, so that would be energy level 1. As we go out, this would be energy level 2. If we had another one out here, energy level 3. So all we're doing is counting how close it is to the nucleus. The further out, the further away from the nucleus you get. So if we think about our electron cloud model and kind of incorporate it into this design of thinking about energy levels, there were some great men that helped us out with these ideas. Mr. Schrodinger, and you might have heard it before of Schrodinger's cat, was some crazy idea where you put a cat in a box and the cat may be dead, cat may be alive, who the heck knows? Kind of a crazy idea. But it kind of helped us see about some ideas about electrons and about where electrons could be and if they were there, if they were in multiple states. And then Heisenberg came up with the idea also of these electrons are constantly moving. So we can't really pinpoint where it's at and know how fast it's going. So when we combine all these kind of historic old dudes and their ideas, we start getting this electron cloud model that kind of gets a little tricky. Okay? So electrons aren't necessarily set in their orbits. This means, if we look at that electron cloud, this is just a possible place that those electrons can be. They aren't going to stay in a one-line path. So you can kind of go back to our track model again, and you know that track people do not run just in one straight line. If they have a lane that they're going to fill up, they might be all over that lane. Same thing with electrons. They have an area where they can be, and they may be anywhere in that area. And all this area is that's all the electron cloud. Electron cloud is just the possible area that an electron can be in. And there are some areas that are more likely for electrons to be in than others. So if we look at these essentially lanes or shells that electrons can be in, the nucleus would be down here. These would be going around that nucleus, and this essentially are these electrons' lanes. These electrons can be moving in any direction in those lanes, and they may even be doing a wave. They're just somewhere in there. They're not following a straight line path. So, the idea that I need you to remember, if you didn't get anything out of the last couple minutes, is that electron clouds are divided into energy levels. And all energy levels R is the distance away from the nucleus. So energy level 1, energy level 2, 3, as it gets further away from the nucleus, more energy. More energy, less energy. So we have one more idea here to add to this. In addition to the fact that there's all those lanes going around the nucleus, these lanes are also divided into different sections. So you can kind of think about this like a theater. If the stage is up front, all of these seats are going around it, and as you get further away, there's more room for different sections to piece out in those levels. The same thing happens with electrons. The further you get away from the nucleus, so now if this were the nucleus, the more sections those electrons could be in. We call these sublevels or just different shapes of electron clouds. As we go through these sublevels in the electrons, or in the atoms, electrons can fit into 4 different sublevels or 4 different shapes outside of that nucleus. So if this is our nucleus, our first sublevel only has 1 shape or 1 section. Our second sublevel has 2 sections. It gets bigger, so we have to start dividing it up. Our third energy level out here has 3 sublevels or 3 different sections that electrons can be in. Fourth has 4. You're kind of getting the idea. As you get further out, there's more sections or more shapes that those electrons can be in. Each of these shapes, so each one of these can hold 2 electrons. So as we're talking about all these shapes, remember 2. Peace, electrons, 2. And we name these shapes S, P, D, and F. There are 4 shapes that we'll go over. 4 sections by the time you get out from the nucleus. So let's talk about this first shape or first section first. It's called the S sublevel. And S, really easy here, stands for sphere. It is sphere shaped. So that means if our nucleus is in the center, this area around the nucleus is where the electrons could be, and it's a sphere shape. First energy level, sphere shaped. Later, as we get further out, there'll be another sphere shape out here. This might be the second energy level and the third energy level. Okay, remember these are only just places where they can be. There's only 1 sphere per energy level, and each sphere can hold 2 electrons. The P sublevel stands for peanut shaped. Or if you don't like peanuts, maybe you're allergic, dumbbell shaped. Okay, so if this is where our nucleus is, we have our sphere shape here in the middle still, and then we have these dumbbell things, or these peanut lobes. So this is the area that an electron can be in. Now you kind of got to think on a 3D level here, and I know that sometimes gets hard and you're like, oh my gosh, Miss Jones, you're hurting my brain right now. But we'll go over this a little bit more in class. But there are 3 P shapes in each energy level. One can go this way, one can go this way, and one can go up and down. Those P shapes have to fit over the entire nucleus and fill that whole 360 degrees around that nucleus. So if there are 3 p orbitals per energy level, each p orbital can hold 2 electrons. That means the entire p sublevel, that p section, can hold 6 electrons total. So S can hold 2, P can hold 6. The D-shape orbital is a daisy, or a double dumbbell, whatever you want to remember that as. This is as we're getting really far out from that nucleus, and there's lots more spaces. Just like in a theater, as you get really far out, you have a lot more sections that people can sit in. So we have our nucleus here. We'll have other shapes surrounding it in the process, and then as we get even further out, we have these double daisies, or double donuts. Not double daisies, double donuts, double dumbbells. All these places where an electron can be. Remember, this is just places where electrons can be. As you get further away from the nucleus, there's more places where the electrons can be. There are 5 d orbitals, or 5 daisies, that can fit around the nucleus per energy level. And so if each one is holding 2 electrons, every d, or daisy shape, can hold 10 electrons total. So S's can hold 2, P's can hold 6, and D's can hold 10. And our final one here, the F orbital. F pretty much just stands for freaky. This orbital, or this shape of where these electrons can be, just kind of crazy. It can look like a dumbbell with a double donut. So here's our dumbbell, here are the double donuts. Or it can also look like a double daisy. So these crazy ones that look like just a bunch of lobes out here in the air, those are really far out from the nucleus. There's lots of space out there, and so there's lots of places where those electrons can be. All these are saying is where those electrons are. Hold on, I lost it. Got it back. All right, so we have 2 electrons that can be held in each F. There are 7 F orbitals that can be out there in that space, so 14 electrons total. This is going to then lead into our final ideas of one thing you have to remember is that electron cloud is divided into energy levels. All that is the distance from the nucleus. So we have our nucleus, energy levels. As you get further out, higher energy. And each of these energies is divided into sublevels, or just a shape of the electron cloud. So there are different shapes that the electrons can be in. Those are the 2 main ideas that you need to remember from this. And finally, this is going to lead us into a filling order. So you might have heard in the past how 2 electrons can fit in the first one, 8 can fit in the second, and all that. Well, we're going to put a little bit more meaning to that. So this is where we're going, right here. This map, that's where all of it's going to lead us. So I know that this is really tricky stuff, tricky, but try and bear with it. And if you have any questions, go ahead and come in and we'll go over it. Otherwise, I will see you in class and we'll talk about this a little bit more.